Right. Let me share my screen. Okay. I really welcome everyone to join Karmada community meeting. Today is April 14th. Just a head up, I'm now joining the meeting from hotel. I'm not sure the network good enough, so I might be get drops. But I will try to join the meeting as soon as possible. Okay, Joe, you are on the first, so would you like to take it away or?
Okay, yeah, I'll share my screen. And
Okay.
uh, so Honkai, we have about an hour today, right?
Yeah.
Okay. So what I'm thinking is I can cover this first topic. Um and then maybe I can just pass it over to Wei Chen and Lee so that they can cover these two topics. And then next time, well, I can cover this topic, briefly go over this, just get your general thoughts, then pass it over
Mhm.
to Wei Chen and Lee. And then for
Okay.
these two, I'm thinking we can just discuss them further in future meetings. What do you think?
Yeah, no problem.
Okay, so let me cover this one. So, as we started to get more teams onboarded to our managed multi-cluster platform built atop Karmada, it started to become more and more evident that reliability engineering would be something that is very important, and that we would have to measure how reliable Karmada control plane, the Karmada control planes are for our varying use cases. So I did a lot of work on that for our managed service and decided that it would be a good idea to share that work with the wider community. So I can quickly go over the approach I took for this. Um, so basically, Karmada's job at the end of the day is to just propagate stuff to member clusters. But there's a pipeline that things go through for that to happen. All right, first you have to talk to the Karmada API server, and then things have to go through this resource propagation flow. So where you do policy matching, scheduling, dependency propagation, work creation, right? And then finally work execution to get units of work propagated to the member clusters. And then
Hmm.
finally status aggregation back to the Karmada control plane.
Yeah.
And with this approach, by looking at the propagation flow, we can then measure reliability at each of these stages. And that's very important because as we start to onboard, well, as we onboard more users, each of which has a different use case, at some point they will be running into bottlenecks. So it's very useful to know exactly at which of these stages those bottlenecks are. And by measuring reliability at each one of these stages, when arise, we can pinpoint exactly at which stage those issues occur.
Hmm.
Um, and the good thing about Karmada is that today we have all the metrics we need from the Karmada control plane components, such as Karmada Controller Manager, for implementing measuring SLIs. And then from those SLIs, we can come up with objectives and time windows to define SLOs, and that's exactly the approach I took. Um, and we have metrics from these components for measuring both um, availability SLOs based on success rates, as well as latency SLOs. I define 13 of them. 12 of these are from the propagation stages, and then the additional one is for measuring cluster sync latency. Let me go back. So I'm not gonna go into all of these into extreme detail, but basically for each SLO, um, it's at one of these stages, and we have an objective that's usually 99.9, and then a threshold. So, and for the SLOs, the availability SLOs based on success rate and latency SLOs based on response time. So the first set is for the Karmada API server. So this one is for availability, basically success rate for the Karmada API server. And objective is 99.9. And threshold is basically success rate. So um, all um, all requests that succeed, excluding like error um, er error responses like 5xxx and 429 errors. That's for availability. Also, this one measuring latency, so API server latency.
Mm-hmm.
Objective again 99.9, and threshold. I just put a number here, but this can be adjusted. This is 0.4, 400 milliseconds is a good baseline. That's for the API server.
Mm-hmm.
Then there's also a set of policy application SLOs. So the first one for availability, measuring success rate for policy application. And then this one is for latency, measuring latency for executing policy application operations. Then scheduler SLOs. This one is for availability, so success rate for scheduling operations, and then latency for how long those operations take. Also, when Karmada scheduler estimator is running, then this one is for success rate or availability for invoking operations and the scheduler estimator. And this one latency for measuring how long those operations take. For resource propagation, um, success rate for syncing bindings to work objects, latency for um, syncing bindings to work objects, um,
Mm-hmm.
success rate for syncing um, work objects to workloads in the actual member clusters, as well as latency for measuring how long those operations take. And this last one is for cluster health status. And this one is measuring latency for um, how long it takes to um, run health checks on the registered member clusters. Those are the SLOs, and I also have some dashboards for them. Um, this is one of them. So here I get a bird's eye view of all the SLOs. I'll go over exactly how I did this, but basically here I have this service called Manage Karmada, and it has 13 SLOs. I don't have a lot of data because all of this is running locally on Kind clusters, and I started those clusters about 30 minutes ago. But on this panel, we can see how the SLOs are performing over time. So for the API server availability SLO, it has always been compliant. It has always been compliant. But
Mm-hmm.
the one for the API server latency one has never been compliant. And the reason for that is because I set a very aggressive threshold. I'm
Yeah, sorry,
asking
sorry. You have said a very aggregated what?
aggressive threshold. For this one, Karmada API server latency, a good number would be 400 milliseconds. In
Yeah.
SLO,
Yeah.
where
Threshold. Okay.
99.9% of all requests finish within 400 milliseconds. But for this test, I'm using a very
Hmm.
aggressive threshold. Instead of like 400 milliseconds, I'm using
Yeah.
something like, I don't remember, I think 5 milliseconds. Or I think it was 100 milliseconds. I don't remember. Which is why it has never been compliant, this one. And we can see all the other ones, how they're performing over time. This is a high level dashboard. I have this other dashboard. This is a more detailed one. And so I have this service called Karmada, and it has all these SLOs, basically all the ones I went over. This panel is showing the SLOs that are currently not compliant. And again, the API server latency one is not compliant. So for API server availability with an objective of 99.9, it is
Hmm.
compliant. But the latency one is not compliant. Objective is 99.9, but only about, say, 70% of them actually, um, only about 70% of the requests actually meet the objective. And these are all the other ones that I went over. All the other ones are in compliance. Um, so that's the SLOs. So that's the first part. The first part is actually defining the SLOs. The second part is actually for alerting based on SLO violations. It's one thing to implement them, it's another thing to defend them. And to defend them, you need some alerting framework. The one that the industry has settled on is, let me go down. The alerting framework that the industry has settled on is this one called multi-window, multi-burn rate alerting framework, popularized by Google SRE. Um,
Hmm.
and with this one, usually the goal is to minimize um, operational toil while ensuring timely issue detection. And there's many ways you can um, create alerts to defend the SLOs, but usually the one people use is this one, the multi-window, multi-burn rate alerting framework.
Hmm.
And this provides you with very good and reliable issue detection while minimizing operational toil. If I go back, um, I can also, well, we can also see that there's some alerts here. I have alerts for all the SLOs. One second, let me pull them up. I'll show an example. So this one is for the SLO measuring um, latency for syncing resource bindings to work objects.
Hmm.
Um, and this one is okay, but
Hmm.
if I look at the one for the API server latency one, it's firing. Yeah, this one is firing. And for firing alerts, you can have a run book with instructions for how to remediate the issue. Right now, I just put a link to Karmada docs. but we can add links to runbooks for all the SLOs so that for an SLO that is getting breached, a user would know what to do to remediate the issue. That's
Mm.
an overview of, let me go back here. So that's an overview of the set of SLOs I implemented
Mm.
and the approach I use to derive those SLOs based on the Karmada resource propagation flow. And the alerting framework used to implement alerts to actually defend those SLOs and alert on SLO breaches. Um, Next, I'm going to talk about how I did this. So there's this tool called SLAF. Um, and it's basically a tool that makes it
Slow.
very, yeah,
Sorry.
it's called SLAF. It's an open source tool.
Mm.
Yeah, it's a tool that you can use um, to define SLOs based on Prometheus metrics. The way it works is very simple. You basically define a spec. So you can say, hey, my service is called Karmada, and these
Mm.
are the SLOs that I need for Karmada. This one we can, for instance, say that is the one measuring API server latency. And for each SLO, you basically define the error ratio. So basically the query that can be used to get all observations.
Mm.
Let me scroll down 1 second. So 1 second.
Ja.
Yeah. So basically and then for each SLO, you first define the error ratio. So the Prometheus query for getting all observations, and then the Prometheus query for all observations that um, or basically all error observations. And along with that, an objective, so like 99.9, and then a time window. By default, the time window is 30 days. That's the first part, defining the SLO. And then additionally, this part is optional. You can create a config for alerting. So for this one, you can have an alert called my service high error rate that will be fired when the SLO is breached. And then
Mm.
once you have this spec, you can then run the tool pointing to the configure spec, and it's actually gonna then generate all of the Prometheus recording rules and alerting rules for your SLOs. And a tool like this is very useful because you do not want to do all of this by hand. This is very time consuming, tedious, and error prone when done by hand. And with this tool, you can just define a spec and keep this
Mm.
version control as part of your repo.
Yeah.
And then just run it, and it will generate all of the Prometheus recording and alerting rules. And these are actually the rules that we can see here. Let me remove this filter. Yeah, so if you look at all the rules with the slav prefix, these are all of
So,
the rules that
uh,
it generated for my SLOs. And for the Karmada
mhm.
one, I can actually show you what the config looks like. Um, so this is the, uh, 1 second, let me bring it up. Where is it? I can't open the file for some reason. Hold on. Let's see. Uh, why can I not? 1 second, let me refresh this. And yeah, and the file won't open up. Or maybe it is. Oh yeah, there it is. I won't go over all of them, but I'll just go over one. So for the Karmada API latency, SLO, I'm basically just using Prometheus metrics from the Karmada API server, is just Kube API server. So I'm just using the Kube API server metrics. This is the total query. Which is using the request duration metric. And then the error query is actually just getting all the errors, and this gives it the error ratio. And then for alerting, I have this alert config, which it used to generate Prometheus alerting rules. Yeah, so what else should I cover? Yeah, I think I'll stop for now. Any questions?
Okay. Can you go back to the slow sloth?
Yeah.
With how to pronounce the
Slough.
yeah sloth. Yeah, here. What sloth? Right. Sloth, right?
Yeah.
Hello. Okay. So we only need to I mean you only need to put the IO spec on Git somewhere.
Yeah.
So what's the generated thing? Who will consume this?
So yeah. I wanted to show how this works. And as an action item, I wanted to hear what you think and whether you think it would be helpful to have a guide. This is a draft, but something similar to this that will provide users with some guidance on how to measure reliability for Karmada. As far as the Slav config, this is also a draft. But basically the way it would work is if we also want to, what I'm thinking is we can, instead of telling people exactly what to do, we can just make recommendations.
Yeah.
So for instance, when it comes to exactly what the threshold should be for an SLO, instead of just dictating what people should do, maybe we can just provide some recommendation. For instance, 400 milliseconds for this one. That's the first part, is just which SLOs should be defined. And then the second part is actually how to actually measure them. And to measure them, you're gonna need something like Slough to generate the Prometheus recording and alerting rules. Using Slough is one option. We can provide a recommendation for
So
Slough. But this you can do without a tool. It's just that if you do it without a tool, is a lot of work, right? You have to
Yeah.
manually um, create a lot of recording rules and relabeling rules. So if you, just for comparison, this config is probably what, I don't know, 20 lines. The generated recording rules and alerting rules are, I don't know, probably
Okay.
like 200 lines code.
So the slough tool is used to generate the rules for Prometheus, right?
Yes. So
Okay.
basically what I did is, this is the config.
Okay.
This is actually the rules it generated. This file is very long. Once it generated this, and then I just loaded those rules into Prometheus. Yeah. And also this dashboard I didn't create by hand. I didn't create by hand. So Slav also comes with an open source dashboard. Let me show you. Yeah, it comes with this dashboard and that people can download and use. You see this?
Hmm.
Yeah, so it comes with the dashboard as well. So using it is very simple. You just define the
Okay.
SLOs. And to define the SLOs, you just need to know which metrics to use. And we have a metrics. That's why I contributed some enhancements to the metrics reference, is because I needed to use them. So this metric reference. So I'm basically just using all these metrics to define the SLOs. Yeah.
Okay. Got it.
Yeah, just let me know what you think. If you think it would be
Yeah.
useful to have something like this, I can write
Yeah.
it.
Sure. I think
Yeah.
it's great. Just want to confirm with you that the guide will help people to get to set up their SRO. Um,
Yeah, I can add that. So right now it's not here. There's no instructions here for doing that.
yeah,
But yeah, if you think that would be helpful, um, I
yeah.
can add that. Yeah.
I think it's sure it will be helpful. Just a small suggestion. Maybe we can get started with a lower, not that aggressive threshold. So,
Yeah. Yeah. So actually, using an aggressive threshold was intentional. It was to show what happens when an
yeah,
SLO is breached. If everything looks amazing like this, right, then you don't know how it's gonna look
yeah,
when
yeah,
things break, right? But when
yeah.
things break, it will look something like this, right?
Mm. Mhm.
Where you only meet, instead of 99.9, you're only meeting about 70% of them. And when that
Mhm.
happens, an alert will be fired for someone to investigate, yeah, to know what's going on.
Mm.
Yeah, but for the thresholds, um, I can, for each one, I can, instead of threshold, I can just say recommended threshold or something and make some recommendation. And for the API server one,
Mhm.
about 400 milliseconds is a sensible number, right? So, and we can make recommendations for these,
I
but
don't,
if
yeah,
people want to change them, they can just change them.
yeah.
Yeah. So as an example, let's
We can
say,
add some
Yeah, go ahead.
I think we can have some statement at the beginning of the documentation, so that they can, or how they can adjust the threshold.
Yeah. That's a good point. So like for instance, for the API server one right now, I'm using 100 milliseconds, right?
Mm.
But changing it to 400 milliseconds would be just a one line change. Just change this to 0.4.
Mm-hmm.
And then just change it and rerun um, rerun the tool, and the tool will update the rules, and then those rules can just get re-uploaded to Prometheus.
Mm-hmm.
Yeah. So I can add instructions for that. Yeah.
Yeah, it looks great. Um, actually, I'm thinking, uh, what we shall do after the get on board on the website. Shall we share this somewhere, or at some events?
The so yeah, that's a good question. I added an ad here.
Yeah.
So I'm gonna be talking about a lot of this stuff at the Observability Summit North America in May.
Oh, May. Okay.
As part of, yeah. So next month I'll be doing this talk
Wow, amazing.
at
Amazing.
Observability Summit, and we'll talk about a lot of these things. Um, but if
Mm-hmm.
you think, I don't know, come at a specific talk, then maybe we can have another talk, I don't know, about something like this. You let me know.
Mm-hmm.
Yeah.
At least we can send a email to the Karmada mail group.
hmm
For the KubeCon, I don't know if we can submit the CFP for North America.
Yeah. Yeah, we can talk more about this.
Mhm.
Um, okay, so as an action item, I'll work on a guide. This is a draft I have running locally. I will
Okay.
polish this and then incorporate some of your comments and feedback. And
Okay.
then once ready, I'll open up a PR.
Okay. Sure. Sound good.
Okay,
Thank you.
cool. Okay, let me pass it to Wei Chen and Lee. And then for these, I'm thinking we can just talk about them in some other meeting. These
Yeah,
two.
sure. Actually, I quickly look at the two issues, and sure, I think that not the urgent things currently.
Yeah. Okay, let me stop sharing and pass it to Wei Chen.
Okay, thank you, Joe.
Okay.
Yeah, thank you so much. Yeah, for me, I just want to briefly follow up on the previous proposal in the last meetings and just show a POC based on the implementation of by following the proposal. And
So, sorry, which I can see. Oh, I
yeah,
see your face.
yeah, can
Yeah.
you see it? Yeah,
Yes,
so
sure.
yeah, so this is just a brief like a brief POC demos by from the implementation by following the proposal. So just show you that it's working and like what's like expected if we implement by following that. And so my demo, the overview will be I will just create a one victim pod, one victim deployments, which consumes
Mhm.
basically all the resource of the member cluster, and then create another victim one, and then you show and then give you a overview of how the events and how the status and how the preemption process will look like. And so for now, I've already created like local Karmada, and then right now I'm on the Karmada API server context, and I've created two priority class which are for preemptions. The lower one will be used by the victim, and the high priority one will be used by the preempter. And then right now I will create a victim deployment, which will first occupy all the resources in the member cluster or cluster one. The propagation policy used by this is just propagate to the single cluster, which oh, sorry. Which only propagate to member cluster one. Yeah. So this will be the deployment. And as you can see, it used 2 CPUs and then create 5 replicas. And in member cluster one, we only have 14 CPUs. And right now it's basically almost full. And we can see that the victim deployment has been scheduled successfully. And this unhealthy is just because the image I use cannot run in the Bloomberg laptop. But I just want to show it does occupy the resources.
Okay, sure.
Yeah. And then you can see the current status, which is scheduled and then to member cluster one and contains 5 replicas. And right now I'm going to create a preempter, which contains the same config, which uses 2 CPU and 5 replicas, and also only scheduled to member cluster one. Remember, and from here, we'll see that the victim deployments are being started being preempted and be set up. It is set up a graceful eviction task, which is doing evictions, and we evicted by using graceful eviction task. You can see the member show the victim is being evicted, and this is the current status. Right now, the preempter will show it's preempting, and the victim will show it's unschedulable because right now there is no resource. And once even if it gets requeue into the scheduler queue by the reservation design that I mentioned in the proposal, it will be blocked by the reservation of the preempter. So right now the victim still cannot be scheduled, and you can see the preempter is running preempting. And then we can also show the events of the both resource. So once it's starting preemption, it will send out the event for like this, initiated. For the preemptor, it will show this is starting initiating the preemptions. And for the victims, it will show it gets preempted by which bindings and in which namespace, what's the priority, and in it for which clusters. And we can also see the graceful eviction. It's being processed by graceful eviction. The pod is evicted by the graceful eviction mechanisms. And then for the right now, since our requeuing logic will not detect the resource summary change in cluster, so I have to manually trigger it. Otherwise, it will need to wait for 5 minutes. But we already have a upstream PR. They're fixing this. So in this demo, I will just manually patch the preempter and show it that it gets re-trigger for scheduling immediately, and then it gets scheduled to the member cluster one, which means it successfully occupied the resources that was occupied by the victim pod. Show you the detailed informations. So for preempter, it gets scheduled and the victim is unschedulable because the resource right now it's occupied by the preemptor. And this is the scheduling success event for the preemptor. And it's pretty much about it. Just show you a brief overview that the whole process will look like. And once we remove the preemptor pod, and then wait for a couple of seconds, the victim pod. Oh wait, the victim. Oh, sorry, I haven't removed it. So the victim pod will be rescheduled because once the deployment get removed, the claim is also cleared.
Mm-hmm.
And since right now it's in unschedulable bindings, so it also needs to wait for a couple of minutes. So I will also need to retrigger it. Once I retrigger it, it will be successfully rescheduled. Let me victim deployment. Yep. And once the preemptor is removed, the victim one can be rescheduled back to member cluster one. So the cleanup logic this is just to show the cleanup logic is correct, that the flame will not block the later scheduling cycles. And
Mm-hmm.
yeah, it's the full process.
Yeah, it looks good. Since we talked about your proposal at last community meeting, that's really impressive. But sorry, I don't have enough time to look into the proposal so far, so I don't have any further comments. But I will start working on this maybe from this week.
Yeah, thank you. Yeah, no worries. Thank you so much. I just want to show a follow-up, like so you have a quick overview on this. Thanks.
Yeah, just a small how to say, maybe not a suggestion or just something I'm thinking in my head is I'm not sure if we need to split this feature to two parts. You know, I remember the first part might not be good for people to use this in production.
Yeah, you mean directly integrate with estimator?
Yeah.
Okay.
So I think I would prefer to get it done directly with the estimator, even though we can split this feature in one or two or more iterations.
Sure.
But
My goal, yeah, sorry.
but anyway, I will leave my comments on the PR, and after I carefully go through the proposal.
Yeah.
I mean, you don't have to update the proposal right now.
Okay.
Mm-hmm.
Yeah, sure. My goal is also like complete both phase in this proposal. I just want to separate them to two, so we can have more clear on the structure. So the first one will like mainly focus on the interface and structure, and the second one will So
I understand. Yeah.
Thank you.
Okay.
And I will hand over to Mihash and Lee. Is it good?
Yeah, it's all Lee.
Okay. Thanks.
Yeah. Hey, so let me share my screen. All right, so it's basically it's something we talk about during the our maintainer summit. It's a new proposal regarding a federate stateful rollover rollout. And I used Flink as an example here. Um, what it does usually what it does is to since Flink itself provide a blue green in cluster migration by out of box, but for if we want to migrate the job between between clusters, the operator itself cannot do that. It doesn't have a view between across the cluster. So that's why I think it's a chance for Karmada to do the stateful um, rollout for Flink. So I create this proposal, and also the use case I put here, simply speaking, is if let's say if a SRE want to do a maintenance of a cluster, it can trigger the cluster, the stateful rollout, and what the controller does is it brings up the job in the other cluster and waiting for it to become healthy, and then terminate the jobs in the original cluster. In that sense, we don't have to wait for like 5 minutes um, um, use the stateful failover mechanism what we already have. Um, that's like more proactive way. And the other use case is like, let's say a developer wants to upgrade a Flink deployment in the other in and put it in the other cluster. The controller can do that without all the manual works. At this moment, if a tenant want to do that, they have to manually suspend the job with save points, and then bring up the other job in the cluster in the other cluster, and then manually patch the save points in the job, because it cannot leverage the checkpoint. It has to use the save point, so the stateful failover doesn't work for them as well. These are the two user stories. Um, and I'll also has a like how to do this in like a state machine step by step, but I don't want to go it in pretty detail. I know we have only 10 minutes left. And just want to get some opinions from you, Hongkai. What's the next step for this proposal? I know you probably think it's maybe it's first to focus on the stateless app, or what do you think?
Okay. Actually, here I want to hear what's Mihar's thoughts on this.
Yeah, so I'm trying to get a better understanding of the use cases. I mean, we talked a little bit during the maintainer summit about this, but like for instance, with Story 2 for image upgrades, for instance, what's preventing the user in this case from updating their image in the same cluster? Like, why do they have to fail over?
Let's say, so the use case I think is two. One, if a cluster is full, I mean they use all of their quota, um, they there's no way you can bring up the green deployment first in the original cluster. So that has to be in the other cluster. The other is, let's say if in the cloud infrastructure, the other cluster, they want to migrate to a cheaper um, cluster. So they like bring up the job in the cheaper cluster, not the same cluster. So those are the two cases I think.
Yeah, so I'm trying to wrap my head around it a little bit more just because with like blue green, yes, there's a case that the cluster could be at capacity, preventing from like the additional replica from coming up. But the way that we usually plan our clusters, we cap the allocations at 75% usually. So um, I don't know if there would be a case where the cluster doesn't have sufficient resources for blue-green. To be fair, we haven't even updated the operator just yet to support this. So I'm curious what it's going to look like once users actually start using blue-green and whether this becomes a problem. Because I think we just don't know yet. But okay, so I see what you mean by that. Secondly, generally with like blue green, the zero downtime becomes useful for cases where users might just be running a single application. Um, and so the way that I've always logically categorized our users' jobs is by determining what is their toleration for downtime, right? So we have users who are completely okay having their applications be down for a couple hours, maybe like 30 minutes or something, right? In that case, like failover itself um, takes more than enough time to allow those applications to come up within what they would expect it to. The case in which I guess zero downtime would be particularly useful is for users who have very high sensitivity to downtime, right? So at the moment, what they do is they schedule two duplicate applications, which is what like we were working on NT-Affinity for, in order to ensure high availability, right? So typically users who are doing an image upgrade, for instance, they do it per application. So it's almost like a blue-green without the, I guess, actual feature being used on the Flink operator side. So perhaps, like I see a case where maybe users don't want to pay extra to deploy two applications. Um, and in that case, they want to use a single application, but still have that sensitivity to downtime, where blue-green might become beneficial. But again, that to me, the problem there is it ultimately still becomes dangerous, right? Because if you're running a sensitive application, you're assuming that like the failover will only happen in cases of maintenance, right? But there are unplanned outages that can occur. And in that case, you're facing downtime, right? Because you're gonna have to wait for that application to get failed over. So I feel like maybe we should be talking to some of our users and see if they would find it useful. Um, but because the last thing that we want to do is just create a feature and then no one's actually using it. Um, so I don't know if you've talked to any of our users about this and whether they would find it helpful, but maybe that would be a good step towards refining the user stories. What do you think?
Uh, yeah. In general, I think the feature probably for Flink is limited, but for for the whole um for the whole Karmada
Mm,
way, as Karmada is higher observer for for the cluster migration, I think yeah, probably it's useful as it can minimize the migration. It's more like a proactive way rather than rely on stateful failover to do that.
mm.
But yeah, I think we can discuss more since we already have 2 minutes left.
Okay, sounds good. Yeah, I would be really curious to hear other use cases for this.
Mhm.
Because I guess we're trapped in like the land of Flink right? If there are cases where other applications or other CRDs require this sort of federated blue-green, then that's great. I haven't done too much personal research about it.
Hello, can you hear me?
Yeah, I can hear you.
Yeah, we can
Yeah.
hear you.
Yeah, my Zoom says I need to rejoin the meeting, but I don't know why. So anyway, actually, what I'm thinking is firstly, I think the use story in this proposal is makes sense to me. But I'm thinking as I talked to many people during the KubeCon EU last month, they told me they need a general rollout feature. I think the scope for the rollout feature might be more the scope might be more larger than this scope. So I think I will start to talking to some guys. Some of them are using Karmada for the some of the guys they are using Karmada and they have built some features on top of Karmada for the rollout. And I want to gather more feedback, more use case from them. Yeah, I think the currently the two user story in this proposal could be included in that feature. But I do know that I agree with Mihash that the two user story might be most complete, might be very complex because we are trying to handle the workloads with data need to be reserved before before migration and need to resume from resume from checkpoint. So it's very complex, but it worth to do, I think.
Okay, so it sounds like we want to go with a more generic and simpler,
Yeah,
simpler way
yeah.
first, and then like this can be a subgroup of later implementation.
I think yeah, I think we can gather some more feedback or more
Okay.
requirements from some guys. I think one guy from Bloomberg is Antony. I don't know if I pronounced it right. Antony.
Antoine.
Antoine.
Yeah.
Antona. Okay. Antona had a use case. I haven't talked to him after the KubeCon though.
I told him
Yeah.
about it. The suspension feature you told me. I told him about that.
Yeah. So generally, I think maybe in addition, so generally speaking, I think we can gather more feedback on how people need in the rollout area, and maybe we need not just the blue green. So maybe we have another other with okay. I think I will share more after I talk to some guys and leave my leave some message on the PR. I just not do this in rush.
Yeah.
Mm-hmm.
I'll collect some use cases or tenant feedback as well to see.
Oh, sure.
Yeah, to give you I'll probably leave comments in the PR as well.
Yeah, maybe you are more familiar than me with the rollout ways in this industry. Yeah, I think I will leave some message on the PR after I talked to someone else. And
So
Sounds
Lee,
good.
maybe you should connect to Antoine as well and maybe combine.
yeah, I hope to, but Lee Wang also can help to
Yeah.
connect. Yeah, right. Yeah, I think generally I think this feature is in our roadmap this year, but just the scope I want to more larger.
Great. Thank you. That's really helpful.
Okay, thank you. Thank you all. I see we have some new friends here.
Hi.
Alice Zheng and yeah,
Hi,
Yun.
Jose. Nice to meet you again.
Nice to meet again.
Yeah, we met in the KubeCon before. And me and Alex are from Bloomberg Spark platform team.
I
And
know you. So we last met at London or
London.
Paris.
London.
Yeah, sure.
Yeah. And we will integrate with Karmada in upcoming quarters, finally. And we are very excited to integrate this open source tool. And we are here just say hello and follow some latest updates. And yeah, thanks for hosting this community meeting. As we move forward, like with deeper integrations, we may reach out with more questions, like for example, around handling dynamic scaling scenarios for Spark. But yeah, looking forward to staying in touch. Jose.
Okay, sure. Alice Zheng, where are you? Where are you? I cannot see your face.
Hi. I think my webcam is on.
Hello, sure.
Hello. I'm new to Karmada and I'm also new to Spark team actually. Just joined the team for a month and yeah, I'm pretty interested in Karmada and I've been trying to do some elastic workload scaling with it, doing some POCs, but this session is really helpful. Thank you.
Okay, thank you. I think you can feel free to ask any question if you and feel free to add a agenda on the meeting notes if you want to talk in the meeting. Okay.
Yeah.
Good, thanks.
Okay, I think it's meeting time is run out and it's quite late here. So let's say see you next time.
Okay. See you next
Bye.
time. Bye.
Bye.
Thank you,
Cheers.
guys.
See you,
Thank you
folks.
all.